Okay, with 7.3, we're going to look at probability distributions for continuous random variables. You don't see them that often because they're kind of hard to do, but we're going to look at one today and kind of walk you through it. So the probability distribution for a continuous random variable x is specified by a mathematical function denoted f of x and is called the density function. The graph of a density function is a smooth curve called the density curve. So there's a couple rules for our density functions. They're very similar to the ones we went over yesterday, but now we're looking at more of like a graph versus a table. So again, one of them is f of x has to be greater than 0. So basically the curve cannot dip below the x-axis. So that's the same thing as when we said in our table, you can't have a negative probability. Same thing. The total area under the density curve is 1 unless otherwise specified. Again, that's very similar to us saying the table's got to add to 1, your graph, the area under the curve's got to be 1. Unless otherwise specified, we're going to look at that today because we're going to do area. So it's going to be not 1, but then when we make fractions, it'll end up being 1. And then this is the third one. This one is just for continuous because you'll see. It's different than discrete. The probability that x falls in any particular interval is the area under the density curve and above the interval. So we're going to do area under the curve. Now those of you who took calculus, don't worry, we're going to keep it simple. We're going to do a lot of rectangles and a lot of triangles. So we're not going to be all crazy and you won't have to do you won't have to have taken calculus to do this. Okay, so here's our big example of the day. Let x denote the number of hours spent working on statistical homework each week. Suppose the density curve is modeled by a piecewise function. So, the bottom of our table here, our graph, this is going to be x is going to equal the number of hours, right, that you're working on math home or stats homework. And then I'm going to leave the y-axis really just alone. You'll see, normally it'll say density over here, but because we're not doing an actual density function, I'm going to leave it. So I'm going to make the x-axis all count by ones. I'm going to make the y same thing. Okay, so we have a piecewise function. So the first one, it's 2x from 0 to 4. So I'm going to start at 0, 0, and I'm going to go up 2 over 1. So you got to remember your algebra. So I'm going to go up 2 over 1 until I get to 4 hours. So that's the first part. I'm going to try and zoom in so you can see it while I'm graphing it. So this was 2x till x equals 4. Then it's negative x plus 12 from 4 to 12. So negative x, so I'm going to start at 12. I'm going to not shade this in, but I'm going to go down 1 over 1. Then down here, once I get to 4, I'm going to go a negative 1 slope. All the way to get to 12. Turn my paper so I can draw my line. So there's our density curve. So it's a triangle. So again, this is the area under this curve is not actually 1, but we're going to take, every time we do a probability, we're going to take the probability of something over the area of this whole triangle. So, let's try the first example. What's the probability that a student spends less than 4 hours, x is less than 4, each week? So if I go over to my density function, or density curve, and I draw a line at 4, I'm looking at less than. So I'm looking at this area. So what I'm going to do, I'm going to make a fraction. I'm going to think the area of the small triangle over the area of the big triangle. So I need to remember triangle area. It's half base times height. So for the small, it's going to be half, the base is 4, the height is 8. So half of 4 times 8. The big triangle, this whole thing, would be half 12 times 8. Because 12 would be the base, 8 would be the height. So this one's 16, 48. So I get a third. So the probability that a student spends less than 4 hours on dad's homework is a third. Okay, what about the probability a student spends between 4 and 8 hours? So now we're looking at the probability. 4 is less than x, which is less than 8. So I'm going to go back to my thing. If I look at 4 to 8, if I had a different color, I would put a different color, but I don't. So I'm going to just shade differently. So I'm looking between 4 and 8. Now, it's a trapezoid. If you remember the area of a trapezoid, feel free to do it. But I can create a line here. Now I have a triangle and a square. So that's how I'm going to add the area together. So I'm still going to do the area of this piece over 48, but I'm going to break this up into 2 small pieces. So this is going to be half of 4 times 4, that's the triangle, that's the top part, plus 4 times 4, that's the square at the bottom, all over 48, because that's the area of our triangle from part 1. So then this is going to be 8 plus 16 over 48, so 24 over 48, so a half. Okay, so the probability a student spends between 4 and 8 hours is a half. Now, the number 3 on the back is what's the probability somebody spends more than 8 hours? So the probability x is greater than 8. So now I'm going to do that last piece. So now I'm going to look at, let's see, we'll go this way, this piece. So again, this is a triangle, so I'm going to put this little triangle on the top, again, over 48. So I'm going to do half 4 times 4 over 48. So 8 out of 48, so a sixth. You could always do 1 minus a half minus a third, because again, you know, and you still get a sixth. Because you know that the whole density curve has to add up to 1. What's the probability that exactly 8 hours are spent each week? So the probability x equals 8. Well, in a continuous function, that's the hard part. It's actually 0. So the area under the curve at a single point is 0. So in this class, anytime I ask you for a single point, you just put 0. Now there is some calculus again behind it, but we're going to skip it because some of you have not taken calculus. So just put 0. Now, usually at some point the students ask me, well, is this greater than 8 or greater than or equal to 8? Does it really matter? It does matter if it's discrete, but in a continuous function, it doesn't matter. The probability A is less than X, which is less than B, equal to, is the same as if one of them was equal to, one of them was not equal to. So they're all the same. So it's equal to the probability A is less than X or less than or equal to B, which is the same as the probability A is less than or equal to X less than B, which is equal to the probability A is less than X less than B. So if you're trying to find, like, I'm going to make a curve, but if you're trying to find the area between A and B, it doesn't matter if it specifies less than or equal to. It doesn't matter. It's all the same. For continuous. For discrete, these are all very different. And then the other thing what we're going to do, and we're going to learn more about this when we get to normal distribution, if you're trying to find the probability of A is less than X less than B, and it's not as easy as finding that trapezoid one, you can take the probability X is less than B and subtract the probability X is less than A. So if I'm trying to find, I call it an in-between. If I'm trying to find an in-between, I can find the area less than B, subtract the area less than A, and that'll give me the in-between. So it just makes life a little bit easier when you're looking at different functions. So we don't spend a ton of time on continuous probability distributions. Like I said, the discrete ones you're going to see more of. So that's why we're only doing one day on this, and it's relatively short. But you should know how to do it. It's, again, just a lot of area.